16 people. Morning. It's the 9th. All right, I think I've got everything. Not quite a third, but hey, that's okay. That's okay. Yeah, a bunch of people online. I don't blame you. All right, let's see here. Let's get. All right, so this is where we left off. Turn that down. All right, inactivity. So before we start, just reminder, we have the quiz. I believe I have it going off tonight at like 11:30. Make sure it gets done. Make sure you do it. Had a question about seeing the quiz. You know, can we see the answers and questions? Yeah, you can. Once it passes the due date, then what you can do, if you've taken the quiz, you'll have to go into your grades, click on the score. So you'll see your grades. You can click on the score, and that should open up the quiz. You'll see all the questions, all the answers, what you gave, you know, all the answers that you gave, and the answers that should have been correct. So you can check that out. If you missed the quiz, you know, forgot to take it for whatever reason, then I think I still have it set. So you can take it, and it gets counted as late. All right, it gets counted as late. But if you didn't take it and you can't see it, then you just go ahead and shoot me an email. What I have to then do is I have to assign a grade, assign a 0, just so you can see it ultimately. I normally don't do that until the very end, but we can do it. So that way you have these quizzes to help study for the exam that's coming up next week Friday. So just a reminder, that exam as well will be online. So I'll come here. I'll be here at 8 o'clock if you want to take it. I won't have any stream, but I'll be here in the room if you wanted to bring your laptop or your tablet and take the exam while you're here in class. So if you had any questions, I can answer them. There will be a time limit on the exam, so once you start it, the time starts. All right? It's not total time working on the exam. It's once you start it, time starts. If you happen to lose internet connection, the way it's set up is that you can just log back in, reestablish a connection, log back in, and you can pick up right where you left off. All right? But the time limit still continues, so before starting that, make sure you have a solid connection. We'll talk more about it next week. So I think my goal is to have it done on Wednesday or by Wednesday, at least most of it. All right. Also, we have the Hardy-Weinberg equation stuff. So that quiz is set up to be due next week Wednesday or next week Tuesday. By the end of the day on Tuesday. So if you have questions, you can bring them to class on Wednesday. That is an unlimited attempt type of quiz, so you can try your hand at it. If you get 100, that's great. If you get, let's say, 90%, and you look back and you say, "Yeah, it was a stupid mistake," hey, maybe you're gonna be fine with that. But if you take it and you get a 25%, go back, retake it, double check your notes, double check the labs on how we actually do these Hardy-Weinberg problems. All right, it's an important concept to know. Those are fill in the blanks. So they are ones where you have to type in your answers. If you are confident that you had it right, you can always email me, and I can go in and check the answers. I probably won't do that until after the due date. I'll go in and manually screen all the answers to make sure that we didn't have any rounding issues. But if you're curious, feel free to email me with those. All right, that is up there. Hopefully it's a free 100% because you can do it unlimited amount of times, but it is definitely a good practice because you will see some of these on the exam. All right, so no lab this week. Hopefully you saw that announcement. Good thing, I mean, it's raining. We did have an outside lab. I don't know if it was last year or the year before, man. It poured, and we were out there in a grass area that was flooded. So it was not the greatest. All right, so this is where we left off. Oh, hold on. Tri-Beta meeting tonight, if you're curious. I think professor introductions. So if you have an idea that you want to do some research later on, now might be a time to attend it to hear what some of the professors are doing. I don't think everyone's going to be there. Some people will be on via Skype or via Collaborate, whatever is going to be used, right? So check it out. All right, inactivity. So we're talking about these tolerance limits. We introduced the law of tolerance. What is the law of tolerance? What does that say? All right, so it says that what kind of conditions? What kind of conditions? No, just generalities. All right, so it's our abiotic conditions, and that's kind of important. I know it's a minor detail, but it's the abiotic conditions that are defining our tolerance limits. It's not really organisms, because it's the interactions then kind of set up this different idea called the niche, so our actual niche space. So this law of tolerance is really just focused on the conditions in which the organism encounters. And the conditions that we're talking about are the abiotic conditions, so temperature, pH, salinity, and all that stuff. All right, so it says we have this area where our organism can live, but we know that oftentimes conditions change, and it puts the organism outside of its tolerance zones. So how can an organism adapt? Well, one way in which it can adapt is to try to avoid the condition altogether. All right? So avoidance can take the form of inactivity. So you can sense the approaching harsh conditions, All right, and then you just become completely inactive. You shut your body systems down, and you wait them out. Hopefully wait for better conditions to arrive. All right, so the benefit of this is that we typically get to survive those harsh conditions. All right, since we're shut down, right, we're not expending any sort of energy. All right, we're not expending energy to thermoregulate. We're not expending any energy to try to conserve water. All right, and because we're shut down, we're not really exposing ourselves to any more of these harsh conditions. Yeah, sometimes these seeds have to deal with freezing conditions, but that's okay. We're in an inactive state where the freezing doesn't negatively affect any of our cells or tissues or membranes and so forth. All right? So survival of the harsh conditions is really, one of the primary benefits of inactivity. The secondary benefit is that we also tend to experience a decreased mortality rate. And that decreased mortality rate comes from predator avoidance. So if we're not active, if we're not moving around, we don't expose ourselves to predators. All right? We don't expose ourselves to predators. And this graph kind of summarizes this. So we have bats that can be hibernators. We have mammals that can be hibernators. The orange lines are our hibernators. The blue lines are not. And the y-axis is graphing survival. So in those organisms that actually hibernate, you see that their survival's higher. And you'd say, well, yeah, no duh, they've become inactive. They've survived the harsh conditions, but all of those that don't hibernate also survive the harsh conditions. They have a fixed survival rate. So why is the survival rate of these other organisms, of these hibernators, higher than the non-hibernators? Well, it comes down to this predator avoidance. These inactive individuals are not out exposing themselves to predators. If you're not out exposing yourself to predators, then you don't have that risk of being hunted and preyed upon by one of these carnivores. All right? So while this inactivity is in response to the harsh conditions themselves, it obtained the secondary benefit of predator avoidance. Any questions on that? All right, so that's inactivity. The second avoidance mechanism that we have is movement. All right, so conditions turn bad. We realize we're in a bad part of our environment. We can't survive it. Let's just move. Seems simple, right? We do it ourselves, right? What did you guys do when you got out of, your vehicle or walked out the door of your dorm room? Did you mosey on over here? Not really. You probably hustled a little bit, unless you wore, like rubber boots and rain gear, and you say, yeah, I love the rain. All right? I didn't. I hustled in. So movement, it's kind of simple, all right? But our movement can take the form of a short distance move or a long distance move. All right? Short distance or long distance move. Long distance movement is what we're going to start with. All right? Long distance movement is basically migration. That's what we're talking about as an avoidance mechanism. All right? What's our definition of migration? Well, it's defined as the seasonal movement from one region to another and back. So we're going to go down to one place, spend some time, and then we're going to return to our original location. That's migration. And it's going to be a long distance move. This map shows waterfowl. And each of these dots, I believe these are tags. So the birds were tagged up at the breeding sites or down at the wintering grounds, and then the hunters reported them. They reported where they obtained the tags. So you know where the birds were initially tagged, and then you know where the hunters got them. And you can see that some of these birds, man, they can travel long distances. You have some of these birds that are nesting up northern Canada. They're all the way down on the Texas coast. It's a very long distance movement. Now, do all of these birds move? Yes and no. So we have our obligate migrators and we have our facultative migrators. All right, some of these birds that are nesting up far north, yeah, those are going to be obligate migrators. They have to move in order to survive the conditions. Some of those other birds that maybe don't make that trip all the way north, maybe they're nesting more down in the mid-states, they might be facultative migrators. They may sense the winter and say, well, I don't really have to move because my winters aren't as harsh as those that are coming down from the far north. All right. You see some of them here. We might have resident populations of waterfowl that don't really leave our area over the winter. And any new waterfowl that come in are obligate hibernators. They're obligate migrators. We would have had a lab where we actually see some of these birds that migrated down. We observe their behavior, form these ethograms, but we had to cut some labs out. I think we had to cut 2 weeks of labs. That's one that we normally do it like right around Thanksgiving, just after, because the birds they're going to be coming down around that time, and there's no guarantee that they're going to be down here in early November. So just had to take it out. Unfortunate. All right, so why migrate? What's the advantage of it? Well, it's going to be advantageous if our harsh conditions, all right, they've got to be harsh conditions, but if these are seasonal, and that means that they're going to be predictable. They're always going to happen. Year after year, they're always going to happen at the same time. And these harsh conditions, them being seasonal, they're going to be predictable. All right? They're signaled by a cue. Something that the organism can sense in the environment to say, hey, conditions are starting to turn bad. Now's the time that I need to start my behaviors to either prep for the migration or to start leaving. All right? If we don't have these, then migration probably isn't going to evolve. Other mechanisms are going to evolve. We need these conditions. We need predictable seasonal conditions, and we have to have them signaled so that the organisms can move. Now, there's pretty big risks associated with migration. All right? Number one risk is that it takes a huge amount of energy resources. This is not a cheap adaptation. All right? Our organisms, they have to save up on food, save up on energy, store this energy. They have to bulk up on muscle mass in reference to the birds. And then as they undergo the migration, they are burning huge amounts of energy. All right, by the time they make it to their wintering grounds, their muscles have basically shrunk. Not because they haven't been using them, but because the birds have been using the protein as energy source to finish the migration. All right, a huge energy cost for migration. That's why we don't see a huge number of species migrating. Second major cost is that increased risk of mortality. Yeah, we're avoiding the harsh conditions, but we're doing so by moving. And we're moving over a long distance, which is now going to increase our risk of predation. We're going to be exposing ourselves to many more predators, many different predators, all right, many different diseases and parasites along our way. All right, we have a chance of encountering really severe weather and not surviving that. And for waterfowl, the risk of humans. What do humans have to do with this? Yeah, waterfowl hunting. All right? We've increased our predation. These are major risks. Major risks, major costs, yet migration has evolved and continues to be a response to these harsh conditions. So the thing to remember is that if migration is going to evolve, if it is going to persist, then the total benefits must exceed these costs. Have they? Yeah. That benefit of moving away from that harsh environment, or moving away from their breeding grounds, their nesting grounds, yeah, it must be a pretty big cost, or pretty big benefit. to outweigh these costs. All right? Questions? So I'm going to point out that both migration and hibernation are two different avoidance strategies to avoid harsh conditions that happen either over a large spatial area or a large temporal scale, so over a long period of time. Things, and you can rationalize that when winter happens, it's all of the north. The reason they call it the Great White North. All right? Harsh conditions over that large area, and it lasts for several months at a time. The response to local or short-term harsh conditions is going to be different. You don't have to undertake these complex physiological adaptations just to shut yourself down to survive one day of chilly weather. All right? You don't have to do that. All right? For these conditions, for these short-term conditions or conditions that happen at a very local scale, all right, our response is simply just to move to a new area. You just move to a more favorable area. It could be moving into a den. All right? It could be moving just into the shade. It could be moving out into the sun. All right? Finding shelter. It doesn't cost a huge amount of energy. It's just basic movement. All right? But what you're doing is moving to an area that decreases your mortality risk to that harsh condition. An example of that we have is behavioral thermal regulation. It's an actual term, behavioral thermal regulation. So thermal regulation is maintaining your body temperature within set limits. All right, that's our homeotherms. All right, they regulate their temperature within narrow ranges. Behavioral thermal regulation does the same thing, but they do so without having any sort of physiological mechanism to maintain that temperature. Right? It doesn't have these physiological mechanisms that say, hey, when I'm cold, I'm going to start increasing energy production or energy burning just to generate energy. All right? If I'm hot, I'm not going to dilate my blood vessels to increase blood flow to the surfaces. All right? We have all of those things. These organisms that undergo behavioral thermal regulation do so by just changing their movement. They change where they are. They change their orientation to the sun. They find shade. And by doing so, what they're doing is usually maintaining their internal temperatures within a fixed range. So it looks like they are thermal regulating when in fact they're doing so through some sort of behavioral mechanism. All right? Our example, who could think of an example? Yeah, I mean, it's hopefully the picture gave you the clue, context clue, right? Reptiles, all right, snakes, basking in the sun, and that's what they can do. So, they can bask in the sun. When they need to increase their body temperature, their core temperature, they go out, move to a bright area in the sun. They sit and they just soak up the sun. If they get too hot, they move. Or in some cases, what they'll do is they'll orient themselves. So perhaps they want to get heat, so they increase how much of their surface area is in direct contact with the sun. If they're a little too hot, they change where they're facing, so that way the sun isn't really hitting them broadside. All right, so these are all ways in which they move. Slight movements can alter their temperature. Second way, instead of just moving, is to alter your activity levels based on the current environmental conditions. So if it's really hot outside during the day, why not just become active in the evening or at dusk or dawn and so forth? So this graph kind of shows those activity levels based on our environmental conditions. All right, and what we're doing is internal temperature and the period of day. So this is time of day in hours, so it goes from 0 to 24 hours, and they marked off daylight and evenings, night. So what you can see is once the organism starts basking, body temperature goes up, and you can see that clouds come over, it decreases solar radiation, their body temperature declines. Then they probably moved to find a better area to raise their temperature, and then you've got your clouds again. And then what they do is start foraging. So they're there warming up getting the energy, and then as soon as it turns night, now we're going to start moving. Now we're going to start becoming more active. All right, why do these guys do that? Some of it has to do with water conservation. All right, if you're going to be moving, you're burning energy, you're using water. All right, well, let's do so when it's cooler out, when it's not as hot. Any questions? Is that what the fire ants? They do. So the fire ants also adjust their activity levels based on our conditions. So they're usually more active in the early morning hours or in the evenings because during the day it's super hot. So I don't know. This is the first time I was exposed. Once I moved to Texas, I had heard of fire ants. I'd never seen them. So it was the first time of actually trying to kill them.
Where did you come from that didn't have fire?
Northwest Indiana. So it was cooler. We had. I don't think they'll make it there. I don't think they'll make it there. We didn't have black widows. I don't think we had. I never had a brown recluse. Rattlesnakes were pretty uncommon, but we had snow. Had to worry about falling through the ice. But on the packages to kill fire ants, they often say if you're using like a powder, it'll say apply in the early morning or late evening because during the day they're probably not out. So yeah, they do it. And then during periods of really high heat, they kind of go away. They'll send out scouts, they'll send out some foragers, but not in the number like that I expect to see in these next couple of days. All right, they've kind of went down in their den. All this rain's going to flush them out. We're going to start seeing more of these fire ant mounds, without a doubt. Other questions? I think that is the end. Okay. Man. I'm trying to decide whether to go on or not. Sit. Yeah, so right here is where we typically end for our exam. And we don't normally get to this place until like Monday or Wednesday of next week. Normally like Wednesday is when we cut it off. So we're ahead. So I don't think I'm going to feel bad to stop here. To give you a preview, so we're dealing with physiological ecology. All right, and the first thing, and why we're doing that is the physiology allows our organisms to deal with these abiotic conditions. All right, we haven't made it to the adaptations that handles the species interactions. All right, predator-prey interactions, reproduction, finding mates. We haven't made it to that. What we're focused on is the abiotic conditions that ultimately determine the range of our species. All right. So we talked about avoidance mechanisms. What we're going to talk about now are the physiological adaptations. So what we'll do on Friday is start with our thermal response. All right? How does the organism adapt to the thermal environment? So hot and cold, what are they trying to do? And I think what we'll probably do is make that the end. Once we get through that presentation, that'll be the end of our exam 1. All right, and then when we come back, we'll talk about water, the adaptations to water conditions or to water environments and anything associated with it. All right, so yeah, I think we'll just stop here, and it's a good stopping point, and we'll pick up on Friday with a new topic. If you have questions, email me. Yeah, what we'll cover our next presentation because I think I already have that presentation. I have the quiz too. The quiz is all made, ready to go, up on Blackboard. That's 15 slides. So I kind of think that we'll finish that on Monday, and we'll probably just cut it off there. So that way you've got the rest of the week to finish. We can take questions on Wednesday. Yep. All right.